reading this very interesting Mr. Tompkins in paperback by George Gamov. Here is Mr. Tompkins, and this is Canto. It's written Canto right here. And Canto is a paperback imprint which offers a broad range of titles, both classic and more recent, representing some of the best and most enjoyable of Cambridge publishing. Mr. Tompkins in paperback by George Gamov, illustrated by the author and John Hookham, Cambridge University Press. Well, this is all about when published and copyright and etc., how many editions, and of course the ISBN number. I'm going to read a little from the foreword given by Roger Penrose. It is an special pleasure to me that George Gamov's two gems concerning the two adventures of Mr. Tompkins and the wonderful worlds conjured up when the speed of light is made small or Planck's constant large, are now reprinted in paperback. Whilst with hindsight one may find details to quibble about, the excitement of these deeply delightful tales remains as fresh with me as it was some 50 years ago when I first encountered them, he writes. Though physics has moved on in many ways, the basic physics of relativity and quantum theory has not changed. By his ingenuity and narrative skills, Gamov was able to transform some of the puzzling and obscure mysteries of this basic physics, a physics which indeed is still modern, into magical and enthralling stories for children. I remember reading or being read the Tompkins stories as a quite young child, and I'm sure that their magic was responsible to a very considerable extent for the great excitement that fundamental physics has held for me for the rest of my life. I still vividly recall the tigers of the quantum jungle and the old woodcarvers' boxes of mysterious colored balls, the nucleons, the realistically flattened bicycle, and the professor calling out the relativistically flattened bicycle, and the professor calling out, just lie down and observe, as he and Mr. Tompkins see their miniature universe collapse inward upon them. It was Mr. Tompkins who made the new physics vivid and real for me as a child, and I'm sure that he will continue to do the same for a great many others. Written in the early 1940s, updated in 1965, Gamov's main concern were the general principles of relativity and cosmology, of quantum theory and particle physics. Has his account become outdated? Except in certain details, the essentials of this physics have not changed, and so Gamov's description remains to this day essentially modern. Perhaps the main ways in which physics has moved forward since Gamov's time relate to particle physics. More particles are known now than in Gamon's day, but there are now good theories to describe them. We know something about nucleon substructure in terms of quarks, and the strong and the weak interactions of particles in terms of gauge theories that underlie what is now known as the Standard Model. The neutrino, whose existence was still enigmatic as Gamov first wrote, is now well established both theoretically and experimentally. With regard to relativity, Gamov's descriptions of flattened bicycle and city blocks are intuitively helpful, but they do not represent what an observer would actually see. Taking the finite speed of light into account, small objects would appear rotated rather than flattened as they flash by. He wrote before black holes were understood, which is a pity in view of the wonderful use that he could undoubtedly have made of them in his stories. The inevitability and the nature of the cosmic singularities that occur in black holes and the Big Bang led us now to doubt the oscillating nature of the closed universe. But Gamov's prophetic judgments concerning cosmology and the origin of universe have profoundly stood the test of time. It remains undecided, as Gamov was undecided whether the universe is spatially open or closed. But the steady state has not survived, as Gamov had predicted, and his Big Bang picture of the universe's origin has convincingly won the day, writes Roger Penrose, October 1992. Now let's see what Gamov has to say in his preface. In the winter of 1938, I wrote a short, scientifically fantastic story, not a science fiction story, in which I tried to explain to the layman the basic ideas of the theory of curvature of space and the expanding universe. I decided to do this by exaggerating the actually existing relativistic phenomena to such an extent that they could easily be observed by the hero of the story, C.G.H. Tompkins, a bank clerk interested in modern science. Now, the initials of Mr. Tompkins originated from three fundamental physics constants: the velocity of light, C, the gravitational constant, G, and the quantum constant, H, which have to be changed by immensely large factors in order to make the effect easily noticeable by the man on the street. That is C.G.H. Tompkins. Interesting, isn't it so? I sent the manuscript to Harper's Magazine and, like all beginning authors, got it back with a rejection slip. The other half a dozen magazines which I tried followed suit. So I put the manuscript in a drawer of my desk and forgot about it. During the summer of the same year, I attended the International Conference of Theoretical Physics organized by the League of Nations in Warsaw. I was chatting over a glass of excellent Polish Major with my old friend Sir Charles Darwin, the grandson of Charles, the origin of series Darwin, and the conversation turned to the popularization of science. I told Darwin about the bad luck I had had along this line, and he said, "Look, Gamov, when you get back to the United States, dig up your manuscript and send it to Dr. C.P. Snow, who is the editor of a popular scientific magazine, Discovery, published by the Cambridge University Press." So I did just this, and a week later came a telegram from Snow saying, "Your article will be published in the next issue. Please send more." Thus, a number of stories on Mr. Tompkins, which popularized the theory of relativity and the quantum theory, appeared in subsequent issues of Discovery. Soon thereafter, I received a letter from the Cambridge University Press suggesting that these articles, with a few additional stories to increase the number of pages, should be published in book form. The book, called Mr. Tompkins in Wonderland, was published by Cambridge University Press in 1940, and since that time has been reprinted 16 times. This book is followed by the sequel, Mr. Tompkins Explores the Atom, published in 1944, and by now reprinted for nine times. In addition, both books have been translated into practically all European languages except Russian, and also into Chinese and Hindi. Recently, the Cambridge University Press decided to unite the two original volumes into a single paperback edition, asking me to update the old material and add some more stories treating the advances in physics and related fields which took place after these books were originally published. Thus, I had to add the stories on fission and fusion, the steady state universe, and the exciting problems concerning elementary particles. This material forms the present book. A few words must be said about the illustrations. And the illustrations are good. Just go through the book, you'll find them really interesting. The original articles in Discovery and the first original volume were illustrated by Mr. John Hookham, who created the facial features of Mr. Tompkins. When I wrote the second volume, Mr. Hookham had retired from work as an illustrator and I decided to illustrate the book myself, faithfully following Hookham's style. The new illustrations in the present volume are also mine. The verses and songs appearing in this volume are written by my wife, Barbara. Just to get you a peek into the book, here are the contents. The city limit, the professor's lecture on relativity which caused Mr. Tompkins' dream, Mr. Tompkins takes a holiday, the professor's lecture on curved space, gravity and the universe, the pulsating universe, then the cosmic opera, quantum billiards, quantum jungles, Maxwell's demon, the gay tribe of electrons, a part of the previous lecture which Mr. Tompkins slept through. Inside the nucleus, the woodcarver holds in nothing, Mr. Tompkins tastes a Japanese meal. Each and every story or incident is so interesting. You need to go through this book for sure. So the introduction is very interesting. From early childhood onwards, we grow accustomed to the surrounding world as we perceive it through our five senses. In this stage of mental development, the fundamental notions of space, time, and motion are formed. Our mind soon becomes so accustomed to these notions that later on we are inclined to believe that our concept of the outside world based on them is the only possible one, and any idea of changing them seems paradoxical to us. However, the development of exact physical methods of observation and the profounder analysis of observed relations have brought modern science to the definite conclusion that this classical foundation fails completely when used for the detailed description of phenomena ordinarily inaccessible to our everyday observation, and that for the correct and consistent description of a new refined experience, some change in the fundamental concepts of space, time, and motion is absolutely necessary. The deviations between the common notions and those introduced by modern physics are, however, negligibly small so far as the experience of ordinary life is concerned. If, however, we imagine other worlds with the same physical laws as those of our own world, but with different numerical values for the physical constant determining the limits of applicability of the old concepts, the new and correct concepts of space, time, and motion, at which modern science arrives only after very long and elaborate investigations, would become a matter of common knowledge. We may say that even a primitive savage in such a world would be acquainted with the principles of relativity and quantum theory and would use them for his hunting purposes and everyday needs. The hero of the present stories is transferred in his dreams into several worlds of this type, where the phenomena usually inaccessible to our ordinary senses are so strongly exaggerated that they could easily be observed as the events of ordinary life. He is helped in his fantastic but scientifically correct dream by an old professor of physics whose daughter, Maud, M-A-U-D, he eventually married, who explained to him in simple language the usual events which he observed in the world of relativity, cosmology, quantum, atomic and nuclear structure, elementary particles, etc. It is hoped that the usual experience of Mr. Tompkins will help the interested reader to form a clearer picture of the actual physical world in which we are living. Interesting, isn't it? I'm going to read a few lines from the first chapter, City Speed Limit. It was a bank holiday and Mr. Tompkins, the little clerk of a big city bank, slept late and had a leisurely breakfast. Trying to plan his day, he first thought about going to some afternoon movie and opening the morning paper, turned to the entertainment page. But none of the films looked attractive to him. Unexpectedly, his eye fell on a little notice in the corner of the page. The local university was announcing a series of lectures on the problems of modern physics, and this afternoon's lecture was to be about Einstein's theory of relativity. Well, that might be something. He had often heard the statement that only a dozen people in the world really understood Einstein's theory of relativity. Maybe he could become the 13th. Surely he would go to the lecture. It might be just what he needed. He arrived at the big university auditorium after the lecture had begun. The room was full of students, mostly young, listening and with keen attention to the tall, white-bearded man near the blackboard who was trying to explain to his audience the basic idea of the theory of relativity. But Mr. Tompkins got only as far as understanding the whole point of Einstein's theory is that there is a maximum velocity, the velocity of light, which cannot be surpassed by any moving material body, and this fact leads to a very strange and unusual consequences. The professor stated, however, that as the velocity of light is 186,000 miles per second, the relativity effects could hardly be observed for events of ordinary life. But the nature of these unusual effects was really much more difficult to understand, and it seemed to Mr. Tompkins that all this was contradictory to common sense. He was trying to imagine the contradiction of measuring rods and the odd behavior of clocks, effects which could be expected if they move with a velocity close to that of light, when his head slowly drooped on his shoulder. When he opened his eyes again, he found himself sitting not on a lecture room bench, but on one of the benches installed by the city for the conveniences of the passengers waiting for a bus. It was a beautiful old city with medieval college buildings lining the street. He suspected that he must be dreaming, but to his surprise, there was nothing unusual happening around him. Even a policeman standing on the opposite corner looked as policemen usually do. The hands of the big clock on the tower down the street were pointing to 5 o'clock, and the streets were nearly empty. A single cyclist was coming slowly down the street, and as he approached, Mr. Tompkins' eyes opened wide with astonishment, for the bicycle and the young man on it were unbelievably shortened in the direction of the motion, as if through a cylindrical lens. So what he goes to describe it as looking through the cylindrical lens, the clock on the tower struck 5, and the cyclist, evidently in a hurry, stepped harder on the pedals. Mr. Tompkins did not notice that he gained much in speed, but as a result of his effort, he shortened still more and went down the street looking exactly like a picture cut out of cardboard. Then Mr. Tompkins felt very proud because he could understand what was happening to the cyclist. It was simply the contradiction of moving bodies about which he had just heard. Evidently, nature's speed limits is lower here, he concluded, and that is why the bobby on the corner looked so lazy. He need not watch for speeders, because even in fact a taxi moving along the street at the moment and making all the noise in the world could not do much better than the cyclist, and was just crawling along. So all of that. So he goes on to write that he borrowed somebody else's bicycle standing near the curb and sped down the street. He expected that he would be immediately shortened and was very happy about it, as his increasing figure had lately caused him some anxiety. To his great surprise, however, nothing happened to him or his cycle. On the other hand, the picture around him completely changed. The streets grew shorter, the windows of the shop began to look like narrow slits, and the policeman on the corner became the thinnest man he had ever seen. "By Jove!" exclaimed Mr. Tompkins excitedly. "I see the trick now. That is where the word relativity comes in." And you please go ahead and read. It's just really awesome. So this is the back cover, George Gamov, foreword by Roger Penrose. Mr. Tompkins in paperback, comprising Mr. Tompkins in Wonderland and Mr. Tompkins Explores the Atom. Since his first appearance over 60 years ago, Mr. Tompkins has become known and loved by many thousands of readers as the bank clerk whose fantastic dreams and adventures lead him into a world inside the atom. George Gamov's classic provides a delightful explanation of the central concepts in modern physics, from atomic structure to relativity and quantum theory to fusion and fission. Roger Penrose's foreword introduces Mr. Tompkins to a new generation of readers and reviews his adventures in light of current developments in physics today. So The Guardian says, enthusiastically recommended to both scientific and general readers. And Scientific American writes, will vastly fascinate the whimsical and also entirely scientific. Cambridge University Press, and this is what is the ISBN 0521 44771-2, Canto. So here, well, to conclude, overall, George Gamov's writings have had a profound impact on our understanding of the universe. His contributions to modern cosmology and science communications remain invaluable. Interesting are his views, such as his proposal for atomic-powered space flight, while visionary remains speculative and has not been widely adopted. His Big Bang Theory, he advocated and accepted and developed the Big Bang Theory. He proposed that the universe began as a hot, dense state and expanded rapidly. His work on cosmic nucleus and the prediction of cosmic microwave background radiation were pivotal in shaping modern cosmology. So actually the key contribution, of course, besides this Big Bang Theory, we have this science popularization. An accomplished science writer making complex concepts accessible to the non-science background audience. Others too. His books 1, 2, 3 to Infinity and Mr. Tompkins series are very popular and influential. And his ability, when you read it, you'll come to know that his ability to convey complex scientific ideas in an engaging and accessible manner has inspired generations of scientists and science enthusiasts. So, well, he is a renowned physicist, cosmologist, who has made significant contribution to our understanding of the universe. And time for you to take up a book and go through it. Happy reading.